One of the big problems that we are facing is that many of the drugs that we used to treat diseases don't work anymore because the bacteria have become resistant to these drugs. So about 700,000 people die every year from preventable diseases. And even here at the McMaster hospital, there are about 12 people who get one of these resistant infections every week. So it's a problem not far away, but it's a problem right at our doorstep and in our community.
What we find is that the bacteria's surface and the physics of that surface can determine how well an antibiotic can work in trying to kill that same bacteria. By imaging this process at 1/1,000,000th the width of a human hair for the very first time, we were able to see findings that were never before seen. We found that this membrane can stop this drug from creating a hole or a pore in the bacteria's surface. And by doing this bacteria prevents this drug from working. In a normal bacteria, if this is the drug, it'll simply insert and create a hole and break the bacterial surface. But now, when the bacteria becomes resistant, it can't poke through. Instead, it'll just lie on its side and the bacteria will be unharmed.
So our findings really help to identify the basic mechanisms of bacterial resistance, which are namely the charge of the bacterial membranes and the toughness of the membranes. And these findings have a great impact on our understanding of bacterial resistance, but also on the development of future antibiotics and possibly the improvement of existing antibiotics.